Let's get started on this. Should probably turn on the lights. Give me a second. All right, let's get going with this thing. All right, so we left on this page, first page of chapter 8, 121. So let's get to reading. Okay, inheritance. All right. Inheritance is one of the cornerstones of object-oriented programming because it allows the creation of hierarchical classifications. Now, I apologize if my reading is slow. It's 6:40 a.m. here, well, 6:37 a.m. So I cannot read loud. Using inheritance, you can create a general class that defines traits common to a set of related items. This class can then be inherited by others or specific classes, each adding those things that are unique to it. In the terminology of Java, a class that is inherited is called a superclass. A class that does the inheriting is called a subclass. Therefore, a subclass is a specialized version of a superclass. That's a nice way of thinking about it. It inherits all of the members defined by the superclass and has its own unique elements. Inheritance basics. To inherit a class, you simply incorporate the definition of one class into another by using the extends keyword. To see how, let's begin with a short example. The following program creates a superclass called A and a subclass called B. Notice how the keyword extends is used to create a subclass of A. Alright, so I already know this. I'm just gonna show it for the sake of the video. Pause the video if you like to read through this. Now we got the mosquitoes showing me. You can pause the video. I'm not gonna go through this whole thing. It's the outcome of the program. All right. Let's bring this a little higher. So you can see the subclass B includes all of the members of superclass A. This is why a sub of B can access I and J and call show IJ. Also, inside sum, I and J can be referred to directly as if they were part of B. Even though A is a superclass for B, it is also a completely independent standalone class. Being a superclass for a subclass does not mean that the superclass cannot be used by itself. Further, a subclass can be a superclass for another subclass. The general form of a class declaration that inherits a superclass is shown here. Class subclass name is then superclass name, body of class. You can only specify one superclass for any subclass that you create. Java does not support the inheritance of multiple superclasses into a single subclass. Again, as stated, create a hierarchy of inheritance in which a subclass becomes a superclass of another subclass. However, no class can be a superclass for itself. Member access and inheritance. Okay, so No class can be a superclass for itself. What probably means is that you cannot do circular reasoning. So A superclass of B, B superclass of C, C superclass of A. You can't do that. In a class hierarchy, private members remain private to the class. This program contains an error and will not compile. Create a superclass, class A, int private int J, private to A. Alright. Okay, class B since A, int J is not accessible here. Alright, because A was declared private. Class access sub B, no B, total is. This program will not compile because the use of J inside the sum method of B causes an access violation. Since J is declared as private, it is only accessed for other members of its own class. Subclasses have no access to it. Remember, a class member that has been declared as private will remain private to its class. It is not accessible by any code outside its class, including subclasses. Alright, a more practical example. Let's look at a more practical example that will help illustrate the power of inheritance. Here, the final version of the box has developed in the preceding chapter. What was developed in the preceding chapter would be extended to include a fourth component called weight. Thus, the new class will contain a box with height, depth, and weight. Mm. This program uses inheritance to extend box, class box. Mm. That construct clone of an object. Okay. All right. Okay. This is the same class as before, so I'm just going to highlight and just pause the video. Okay, so the output from this program is shown here. Okay. So box weight inherits all of the characteristics of box and adds them the weight component. It is not necessary for box weight to recreate all of the features found in box. It can simply extend box to meet its own purposes. Let's bring it up a little bit. A major advantage of inheritance is that once you have created a superclass that defines the attributes common to a set of objects, it can be used to create any number of more specific subclasses. Each subclass can precisely tailor its own classification. For example, the following class inherits box and adds a color attribute. So another unique subclass. Here, box is extended to include color. Okay, color box extends box. Int C. Int color. Right. Color here is an int. All right. Remember, once you have created a superclass that defines the general aspects of an object, that superclass can be inherited from specialized classes. Each subclass simply adds its own unique attribute. This is the essence of inheritance. This is working more or less like an interface, except that you have already defined some attributes. Okay, a superclass variable can reference a subclass object. A reference variable of a superclass can be assigned a reference to any subclass derived from that superclass. Okay. You'll find this aspect of inheritance quite useful in a variety of situations. That can be a little confusing because the reference is to an object, if I'm not mistaken, not to a class member. So you have to first access the class member to the subclass object, and then that object can be referenced by the superclass, if I remember correctly. Okay, class reference demo. Box weight, new box weight. Bo box, plain box, new box. Okay, volume, weight box volume. Okay, assign box weight reference to box. Reference, plain box, weight box. Okay. Okay, plain box is a box. All right. Yeah. So weight box is a subclass, and plain box is the superclass. So the superclass is being given the reference to the weight box object. Yeah. Okay, volume plain box. Okay, volume defining box. Okay. Volume statement is invalid because plain box does not define a weight member. Weight of plain box is plain box sub weight. So there you go. So you can access the object but not the class variables of the superclass. Yeah. Here, weight box is a reference to box weight objects. A plain box is a reference to box objects. Since box weight is a subclass of box, it is permissible to assign plain box a reference to the weight box object. It is important to understand that it is the type of reference it is the type of the reference variable, not the type of the object that it refers to. That determines what members can be accessed. That is, when a reference to a subclass object is assigned to a superclass reference variable, you will have access only to those parts of the object defined by the superclass. This is why plainbox can access weight even when it refers to a box weight object. Hmm. But if you think about it, this makes sense because the superclass has no knowledge of what a subclass adds to it. This is why the last line of code in the preceding fragment is commented out. It is not possible for a box reference to access the weight field because box does not define one. Although the preceding may seem a bit esoteric, it has some important practical applications to which are discussed later in this chapter. Okay, but still, he didn't mention the workaround of referencing an object of a subclass that in turn references its own variable. You will have already the details of it. All right, so using super. In the preceding examples, classes derived from box were not implemented as efficiently or as robustly as they could have been. For example, the constructor for box weight explicitly initializes the width, height, and depth fields of box. Not only does this duplicate code found in the superclass, which is inefficient, but it implies that a subclass must be granted access to these members. However, there will be times when you will want to create a superclass that keeps the details of its implementation to itself, that is, that keeps its data members private. In this case, there will be no way for a subclass to directly access or initialize these variables on its own. Since encapsulation is a primary attribute of object-oriented programming, it is not surprising that Java provides a solution to this problem. Whenever a subclass needs to refer to its immediate superclass, it can do so by the use of the keyword super. Alright, this can be tricky too. Super has two general forms. The first calls the superclass constructor. The second is used to access a member of the superclass that has been hidden by a member of a subclass. Its use is examined here. Alright. Okay, so using super to call superclass constructor. A subclass can call a constructor defined by the superclass by use of the following form of super. Super argument list. Here, argument list specifies any arguments needed by the constructor in the superclass. Super must always be the first statement executed inside a subclass constructor. To see how super is used, consider this improved version of the boxweight class. Boxweight now uses super to initialize its box attributes. Alright, so boxweight extends box, double weight. Okay, initialize width, height, and depth using super. So boxweight double super, yeah, as constructor, wait, yeah. This avoids code duplication because the constructor for box already has these assignment statements for the weight, the height, and the depth, which I think we actually saw in this one. Uh, Here, there you go. That's the assignment statement for this. Okay, so that's a constructor. It has already the assignment statement. The only thing is that this is, well, it has an overloader constructor, so there is assignment statement. So that's the constructor that is called in this version. All right, and let's go back. Okay. Here, box we call super with the arguments WHD. Discusses the box constructor to be called, which initializes weight, height, and depth using these values. Boxway no longer initializes its values itself. It only depends to initialize the value unique to it. Wait. This leaves box free to make these values private if desired. In the preceding example, super was called with 3 arguments. Since constructors can be overloaded, super can be called using any form defined by the superclass. The constructor executor will be one that matches the argument. For example, here is a complete implementation of boxwords that provides constructors for various ways. Okay. All right. For various ways that a box can be constructed. In each case, super is called using the proper arguments. Notice that width, height, and depth have been made private within box. Oh, yeah. Okay, a complete implementation of box weight. Class box private. Oh, now they're private. Yeah. That means that the subclasses can see them. Okay. Okay. Construct clone of an object. That's the first constructor of box. This is the second constructor overloaded. Okay. The third constructor. And queue is created. And of course the volume computer. Okay, Boxway now fully implements all constructors. You can stop the video and pause it. I'm not going to go, I will not go through all of this because I already know it. Yep, implement everything from the superclass, from the box class. So you already know how this will go. Pause the video if you like to. I think this is the same. Okay. All right. 180. Okay. Okay. So let's keep going. Pay special attention to this constructor in box weight. Construct clone of an object. Box weight. Box weight object. Super object weight equals to object weight. Yep. Note that super is passed on object of type box weight. Yep. Not of type box. Yeah, that's what we read on the previous pages. This still invokes the constructor box object. As mentioned earlier, superclass variable can be used to reference any object derived from that class. Thus, we're able to pass a boxway object to the box constructor. Of course, box only has knowledge of its own members. This would be the key concept behind super. When a staff flag calls super, it is calling the constructor with immediate super flag. The super always. Okay, I think we're good now. Okay, as super always refers to the superclass immediately above it. Okay, something is making the system overload. I don't know why, because I have my Mac on sandwich mode, and the only things that I have open is OBS, the preview app, and the sticky notes app. That's it. So I don't know why CPU spiking up to 69. Okay, this is weird. Oh, wait. Is that just a moment? Okay. No. Okay. Right. So weird. Okay. Yeah. Sorry. Let's go back. Okay. Let's see. Okay, so this is true even in multi-level hierarchy or hierarchy. Also, super must always be the first statement executed inside a subclass constructor. Okay. That's a little bit of let's take a look here. Let's go back up. Okay, so box, and where's box weight? Box weight. See, box weight is inside its own constructor. I mean, super is inside box weight's own constructor. So let's read that again and see if it makes sense. Super must be the first statement executed inside a subclass. Oh, inside the constructor of a subclass. Okay. Inside its own constructor. Okay, good. All right. The second use for super. Super, the second form super acts somewhat like this, except that it always refers to the superclass of a subclass in which it is used. Its usage has the following general form: super, or supper, member. Here, member can be either a method or an instance variable. This is the second form of supper is most applicable to situations in which member names of a subclass hide members by the same name in the superclass. Consider this simple class hierarchy. Okay, using super to overcome name hiding. Class A int I. Create a subclass by extending class A. Class B extends class A int I, so it has its own member with the same name. This I hides the I in A. B int A int B. Super dot I is assigned a I in A. I B I in B. It makes sense. What's the bit if you need to get it? All right. All right. Although the instance variable I in B hides the I in A, a super allows access to the I defined in this superclass. As you will see, the super can also be used to call methods that are hidden by a subclass. All right. Creating a multi-level hierarchy or hierarchy. Excuse me. Okay, up to this point, we have been using simple class hierarchies that consist of only a superclass and a subclass. However, you can build hierarchies that contain as many layers of inheritance as you like. As mentioned, it is perfectly acceptable to use a subclass of a superclass of another as a superclass of another. For example, given three classes called A, B, and C, C can be a subclass of B, which is a subclass of A. When this type of situation occurs, each subclass inherits all of the traits found in all of its superclasses. In this case, C inherits all aspects of B and A. To see how a multi-level hierarchy can be useful, consider the following program. In it, the subclass box weight is used as a superclass to create the subclass called shipment. Shipment inherits all of the traits of box weight and box and adds a field called cost, which holds the cost of shipping such a parcel. Excuse me. Extend box weight to include shipping costs. Okay, so it starts with box. Again, we write the same class, so I'm just going to, you can pause the video. Just going to highlight it for the sake of the video. Excuse me. Okay, just pause the video. Excuse me. All right, so I know exactly what this is doing. So I'm not gonna pause here to go over it. Just pause the video and analyze it. Okay. Because of inheritance, shipment can make use of previously defined classes of box and box, adding only the extra information it needs for its own specific application. This is part of the value of inheritance. It allows the reuse of code. This is part of the value of inheritance. Now, illustrates. Oh, this example illustrates one other important point: super. Always refers to the constructor in the closest superclass. Well, that's the same point he made earlier. The super in shipment calls a constructor in boxway. The super in boxway calls a constructor in box. In a class hierarchy, if a superclass constructor requires arguments, okay, in a class, uh, in a class hierarchy, if a superclass constructor requires arguments, then all subclasses must pass those arguments up the line. This is true whether or not a subclass needs arguments of its own. In the preceding program, the entire class hierarchy, including box weight, and shipment, is shown all in one file. This is for your convenience only. In Java, all three classes could have been placed in their own files and compiled separately. In fact, using separate files is the norm, not the exception, in creating class hierarchies or hierarchies. When constructors are executed, all right? When a class hierarchy is created, in what order are the constructors for the classes that make up the hierarchy executed? For example, given a subclass called B and a subclass and superclass called A, is A's constructor executed before B's or vice versa? The answer is that in a class hierarchy, constructors complete their execution order of derivation from superclass to subclass. Further, since super must be the first statement executed in a subclass constructor, this order is the same whether or not super is used. If super is not used, then the default order parameterless constructor of each superclass will be executed. The following program illustrates when constructors are executed. Okay. Demonstrate when constructors are executed. Create a superclass, class A, system print line inside A's constructor. Create a subclass by extending class A. Excuse me. Class A extends class B extends class A, B system print line inside B's constructor. Class C extends B, and same. Okay, calling constructors. Public static void. Okay, C. They made a class C object. New C. All right. The output from this program is shown here. Set A, set B, set C. Pretty cool. Very, very cool. As you can see, the constructors are executing order of derivation. If you think about it, it makes sense how constructors will be the execution order of derivation because the superclass has no knowledge of any subclass. Any initialization it needs to perform is separate from and possibly prerequisite to any initialization performed by the subclass. Therefore, it must complete its execution first. Method overriding. In a class hierarchy, when a method in a subclass has the same name and type signature as a method in a superclass, then the method in the subclass is said to override the method in the superclass. When an overridden method is called through a subclass, it will always refer to the version of that method defined by the subclass. The version of the method defined by the superclass will be hidden. Consider the following. Method overriding class A int J. Okay. That's the constructor. Here's the method. Display show. Okay. Class B things A. Okay. Int super AB. Let's see. Display K. This override show. Okay. Yeah, because it's the same name. Okay, so class override B. Yeah. The output produced with this program is shown here. K3. Yeah, you gotta put super in front of it. Oh, what's going on here? Alright, for some reason I cannot invoke the larger thing here. So let's just do it like this. When show is invoked on an object of type B, the version of show defined within B is used. That is, the version of show inside B overrides the version declaring A. If you wish to access the superclass version of an overridden method, you do so by using super. For example, in this version of B, the superclass version of show is invoked within the subclass version. This allows all instance variables to be displayed. All right, that's it. That's B extends A. B. Okay. Show. Okay. Super show. That's show. Yeah, that's invoking A. Show. Yeah. If you substitute this version of A into the previous program, you will see the following output. Mm. Here, super show calls the superclass version of show. Okay, method overriding only occurs only when the names and the type signatures of the two methods are identical. If they're not, then the two methods are simply overloaded. For example, consider this modified version of the preceding example. Methods with differing type signatures are overloaded, not overridden. Okay, so that's only when they're identical. That's a void show. Okay. Show. Now this one has a different signature, string message. Overridden show. This is K. Show B. Right. Okay. This version of show takes a string parameter. This makes its type signature different from the one in A. 6 non-parameters. Therefore, no overriding or name hiding takes place. Instead, the version of show in B simply overloads the version of show in A. Hmm. Dynamic method dispatch. Huh. I never heard the term. Interesting. Okay, let's see. Well, the examples in the preceding section demonstrate the mechanics of method overriding. They do not show its power. Indeed, if there were nothing more to method overriding than a namespace convention, then it would be at best an interesting curiosity, but of little real value. However, this is not the case. Method overriding forms the basis for one of Java's most powerful concepts, dynamic method dispatch. See, I didn't hear that in the course that I took. Dynamic method. This is why I thought I wanted to read this book, even though I'm certified in Java. It's because I know this book is a complete reference, is a thorough reference of the whole language. And the course that I took covers every major concept, but it's meant to just get you going, not to let you know the, fine details. So, so this book, I'm so glad I got it, both the physical and digital version. By reference 13, this is version 12. Okay. Dynamic method dispatch is a mechanism by which a call to an overridden method is resolved at runtime rather than compile time. Ah. Dynamic method dispatch is important because this is how Java implements runtime polymorphism. Excuse me. All right. This is how Java implements runtime polymorphism. Ooh. Okay. Let's make that up. Let's begin by restating an important principle. A superclass reference variable can refer to a subclass object. Java uses this flag to resolve calls to overridden methods at runtime. Here's how. When an overridden method is called through a superclass reference, Java determines which version of that method to execute based on the type of the object being referred to at the time the call occurs. Thus, this determination is made at runtime. When different types of objects are referred to, different versions of an overridden method will be called. In other words, it is the type of the object being referred to, not the type of reference variable. Okay, In other words, it is the type of the object being referred to, not the type of the reference variable, that determines which version of an overridden method will be executed. Therefore, if a superclass contains a method that is overridden by a subclass, this version of the method will be executed. Therefore, if a superclass contains a method that is overridden by a subclass, okay, then when different types of objects are referred to through a superclass reference variable, different versions of the methods are executed. Okay, so this is good. Excuse me. I'm sorry, I've been up all night, I haven't slept anything. Here's an example that illustrates dynamic method dispatch. Okay. Call me. System pronounce inside call method. B override call me. System pronounce inside B is call method. Okay. Instance A call me system inside C. Okay. Okay. A object static void. So C is not a subclass of B. Only of A directly. Okay. Uh, new A, object type A, new B, object type B, C, object type C. Okay. A R in a reference of type A. R equals A. R refers to an A object. Wait a minute, where is that object? Oh, that's here. Okay. R call me calls A's version of call. R B B refers to B object. Call me calls B's version of call me. C refers to C object calls C's version of call me. Okay. Inside A is called method. Inside B is called method. C is called method. Yeah. Okay, so this program creates one superclass called A and two subclasses of it called B and C. Subclasses B and C override call me declaring A. Inside the main method, objects of type A, B, and C are declared. Also, a reference type of A called R is declared. The program then in turn assigns a reference to each type of object to R and uses that reference to both call me. As the output shows, a version of call me executed is determined by the type of object being referred to at the time of the call. Had it been determined by the type of the reference variable R, you will have CO3 calls to A's call me. Make sense? Okay. Come on. What's going on here? All right. Note. Readers familiar with C++ or C# would recognize that overridden methods in Java are similar to virtual functions in those languages. Excuse me. Why overridden methods? As stated earlier, overridden methods allow Java to support runtime polymorphism. Polymorphism is essential to object-oriented programming for one reason. It allows a general class to specify methods that would be common to all of its derivatives, while allowing subclasses to define a specific implementation of some or all of those methods. Overridden methods are another way that Java implements the one interface, multiple methods aspect of polymorphism. Part of the key to successfully line polymorphism is understanding that the superclass and subclasses form a hierarchy which moves from lesser to greater specialization. From lesser specialization to greater specialization. So the superclass is broad general, and the subclasses are more exclusive. Okay, so used correctly, the superclass provides all elements that a subclass can use directly. It also defines those methods that the derived class must implement on its own. This allows the subclass the flexibility to define its own methods, yet still enforces a consistent interface. Thus, by combining inheritance with double-written methods, a superclass can define the general form of the methods that will be used by all of its subclasses. Dynamic runtime polymorphism is one of the most powerful mechanisms that object-oriented design brings to bear on code reuse and robustness. Hmm. The ability of existing code libraries to call methods on instances of new classes without recompiling while maintaining a clean abstract interface is a profoundly powerful tool. Oof, that's true. Okay. Applying method overriding. Let's look at a more practical example that uses method overriding. Let's see. The following program creates a superclass called figure that stores the dimensions of a two-dimensional object. It also defines a method called area that computes the area of an object. The program derives two subclasses from figure. First is rectangle and second is triangle. Each of these subclasses overrides area so that it returns the area of a rectangle and a triangle respectively. Okay, figure, dimension 1, dimension 2, figure, that's the constructor. Double A, double B. Okay, double area, yeah, area for figure is undefined, return 0. Okay. As rectangle extends figure. Rectangle, double, yeah, so that's the, okay. The constructor, which is called the constructor for figure, get to assign the first and second dimensions. Double area. Yep. Figure. Define areas. Figure F. Figure. Figure a rectangle R. New rectangle. Okay, it's probably gonna be 3. Oh yeah. Triangle T. New triangle. Figure. Big reference. Okay. Oops. Let's bring it up a little bit. Okay, so fig reference, figure rectangle, I think. Let's see. Oh no, that's F. Oh yeah. So the rectangle reference is important to figure. Rectangle triangle is figure reference, and figure reference. Okay, its own reference basically. Okay. Yep. Okay. Through the dual mechanisms of inheritance and runtime polymorphism, it is possible to define one consistent interface that is used by several different yet related types of objects. In this case, if an object is derived from figure, then its area can be obtained by calling area. The interface to this operation is the same no matter what type of figure is being used. Okay, so we are about to finish this particular recording. Well, let's look at what it says here. Okay. Yeah, let's finish this up. We're going to start on page 191, and we will continue in a little bit. Okay. Thank you. Peace.